More soldering, more wires, and LEDs. Welcome to Hack a Week. So as you recall, I've got a Lucas headlight bucket assembly here off an old Triumph. I picked that up on eBay. There's the part that holds the bulb. There's a socket there that holds a special bulb made by Lucas. And I found some of those bulbs on eBay from Ham Cycle, a seller called Ham Cycle, and for 10 bucks. And then it says in the details that you get 2 for 10 bucks because he says, I'm a nice guy. Well, I got them today. Not only did I get 1, 2, I got 3. The guy threw in an extra bulb. He says in a little note, I gave you a bonus bulb. Signed Ham. So, hey, Ham, thanks a lot. If you need some really cool vintage parts for some of the older bikes, check it out. I looked on his store. He's got all kinds of stuff for the old Brit bikes. So we've got bulbs here now that will fit in here. And I've got a bulb holder on the way, the socket that supplies the power to it. Wow, look at that. Original, new old stock Lucas bulb. High and low beat. Made in England. So this should fit right in here. There's a little notch on it where it lines up to make sure that it's got the proper orientation. Look at that. Slides right in there like a glove. So hopefully in another day or so I'll have the holder that goes on the back that has the wiring on it. I also got some more of these little clips right here. I ordered some of those too. They should be here tomorrow. So there we go. Cool. Thanks a lot, Ham. 3 bulbs for 10 bucks. New old stock. What a cool deal. I've done a bit of rework in this area too in prep for the battery being mounted back here. I've got some 4-gauge wire that I ran from the starter solenoid and from a ground back to here. And I flipped over that rectifier. Lots of people had the recommendation of getting that thing out in some air so it can stay cool. Even though it is heat sink now on a piece of metal, that's a great idea. I've got all that room down there, the air can just flow past it, and I can be assured that it will not overheat. I don't want to burn that out and have to replace it. So the battery's going to go up in this area right about here somewhere, and I'm really hoping that this little battery is going to hold up. If it doesn't, I may have room in here to rework it for another larger battery with more cold cranking amps, maybe a little shallower. I could maybe go with an AGM battery, a little bit smaller, but I'll do some research. Maybe I can find a battery that's got more cold cranking amps to fit in there, but for now we're going to give this one a try. The gauges are rewired now, hooked up right here. That wasn't too difficult. All nice and shrink wrapped, nice and neat. This is the stuff for the lights that will go right here. Left and right turn, oil, pressure, and high beam. I've got a key switch here that I reworked. It's off from another bike, but it's been taken apart in the back, and I routed it out actually to get at the contacts, the copper contacts, and then I just soldered it up to suit my needs. It's a 3-position switch, but I've got it set up where it just the first position turns everything on, and it'll start up like that. See the tachometer's working there. Carbs are almost out of gas. So that takes care of that. I need to build the little box here now, the plate that goes across here. This will go this way, bend down, and then a tab will bend out forward, and the key switch will mount right there. Well, let's start out with some graph paper. Make a few lines here where things need to go. Basically just get a rough idea of where I need to fold everything. Okay, it's a good enough starting point. Just draw a line like so. Let's cut that out and fold it up. Get a little measurement here of the depth where I want the key switch to go. Right about there. Voila, template. There we go. There's the left turn, right turn, high beam. The oil light will be there and the neutral light will be there. These are the holes where it mounts on the old handlebar bosses. This hole is for the ignition switch, and it will be bent about like so. This won't be 90 degrees, it'll be just a bit of a angle like that to stick it out past this area so that the wires can come up in for the lights. The lights, incidentally, will be LEDs. So there we go. That's the template. That's the plan. Now I just got to get a hunk of aluminum and cut that out and bend it and drill it and mount it and wire it and all that jazz. So I pulled it outside, fired it up, let it run a little while. Just did an oil change the other day, finally. Put Mobil 1 in, 1550, brand new filter. Seems to be a little happier now. Charging system's working okay, putting out about 14.25 volts. And it's ticking away like a watch. I got the idle cranked up a little bit just to keep the oil pressure up. And I get to check out my radiator cap temperature sensor to see just how well that works. Sounds pretty good. I don't think I can let it sit here too long like that. I'll let it go until the fan kicks in just to make sure that runs, and then shut it down, let it cool off. Nice to hear it run though. Mailbag time. Got some goodies today for the motorcycle. Let's open them up and check them out. Let's see, this should be yep, there it is, the socket, the light socket for the headlight. Let's see, the two close ones line up there, is that right? Can only go one way. There we go. Looks like that goes on like that and turns like that, and voila! There is a bulb in there with a holder now. Okay, this stuff here should be the clips. Yes, indeed. Put dents in your fingers putting those on. Whoops. Cool. That will definitely tighten that up a whole lot once I get those put on. Next up, from Motorcycle Superstore, we have front brake line, and there's all kinds of crap in here. Marketing paraphernalia and whatnot. Catalog, packing material, and let's see. Nine-inch brake line. Boy, it looks really short, but I guess it's gonna work. Oh boy, 10% off next order. And here's a couple of banjo fittings for that. Should replace the ones that are on the bike now. And the way these work is, this is just a universal end, so these screw on thusly, and I can just adjust them pretty much at whatever angle I need to and mount that up, because I only need to go from the clip-on down to a little lower on the fork. Really short throw, so cool. Love the Mailbag stuff. I got the new brake line installed, and of course a little bit of air got in the system. This is my little trick, at least on these Honda master cylinders and ones like this. If you just give it a short stroke squeeze, not a big long one, just keep working it a little bit like this at a time, you'll work the air bubbles out. I'm almost at the tail end of that, in fact, right now, and there we go. I've got a firm brake lever again. But just short strokes like that, and the bubbles will eventually work their way up, and that way you don't have to try to push the air down through it to the bleeder. I mean, that's an okay way to do it, but this is a pretty good shortcut. If you just changed the line up at the top, or if you had to crack a fitting loose, there you go. Here's the template for the indicator lights glued to a piece of aluminum. Let's see, what is this stuff? 063, 63 thousandths of an inch thick. I think it's T4 aluminum. Anyway, I found it in the scrap pile at work, and I've got it all laid out there. And I pre-drilled the holes with a 16th inch drill bit. Now I'm going to come back with a 1/4 inch for the LEDs, and then got to figure out what size for the mounting holes. Anyway, let's get drilling. Time for a new unibit soon, to take some of those donations I get and go buy a new unibit. This thing is dull. Well, I was just wiring up the headlight, and like I said, I got these vintage new old stock Lucas bulbs, but slight problem. You tell me what's wrong with that picture. Read that label. Yeah, 6 volt. Oops. This thing's 12 volt. Yeah, and I just hooked it up, and it went really bright and really quickly burned out. So both of them, high-low beam, gone. I got to find a workaround for that now. Okay, so I've got everything laid out here to put the LED panel together. The panel's all finished and painted up. All those holes will be filled with LEDs, except for the 4 around the edges. That's the ones that hold the panel to the bike. So I've got LEDs here from Radio Shack, just little ones that come in the packages. They cost maybe $1 something each. And I've got little LED holders. These are really handy. They just go in a 1/4 inch hole, and then the LED of that size snaps right into them. So when you're hooking up LEDs on a motorcycle, or anything for that matter, very rarely can you just use the voltage you have there and hook the LED directly to it. There's a few things to factor in. Now let's see, I've got one here that's a blue one. It's rated at 3.7 volts. The other one is 2.6 volts. This one's rated at 3 volts. This one's rated at 3 volts. I've got a 12 volt supply. If I connect 12 volts to one of these, it's just going to burn brightly really quick and then poof, be gone. So what you have to do is you have to put a resistor in line. A resistor is a device that limits current flow. This is what they look like. Probably not going to be able to see that too well. It's got little stripes on it, and the little stripes are a color code to tell you what the ohms rating is. The ohms is a function of how much resistance the device has. On the back of my Hack-A-Week card, I have a resistor chart. You can look these up online. They're all over the place. Just do a Google image search for resistor chart. You can see over here on this side are the colors, right? And then the stripes. And it's pretty self-explanatory. The first digit, second digit, and the third digit. The first and second have colors to them. And then the third one is the multiplier. For instance, I need a 470 ohm resistor on a couple of these. So if you go to the first column, the first stripe would be yellow. That's the one that corresponds to 4. I'm trying to hold this still. The next one would be violet. That's number 7. So that's 4, 7. And it's 470. So that would be 47 times 10. So in the third row, the multiplier stripe would be a brown one. So that would be, let's see, that would be yellow, violet, and brown. And so, whoops, right here is a 470 ohm resistor. You can see the stripes on it, yellow, violet, and brown. So that's what I would use on a couple of these. Now, how do you determine what size resistor you need for a given LED? Well, there's a few things on here to pay attention to. First of all, you need to know the operating voltage you have, in this case 12 volts. Then you need to know what the voltage is that the LED is rated at, and these vary a little bit. Then you also need to know what the milliamps are. So I'm going to bring you over here and show you this really nifty calculator that you can look up online. I'll post some links to all this stuff on the project page on the Hack a Week website. Just look for the Sabre Cafe project, part number 14, and we'll take a look at it. So let me show you this calculator here. Okay, so there's the web page open. There's the parameters we're worried about: source voltage, the diode forward voltage, and the diode forward current. Now let's take a look at one of these. They usually have the specifications printed on the back, or you can look them up online as well. So right there you can see it says forward voltage is 3 volts. And if we dig around a little further here, somewhere we're going to find, there it is, right in that last line, outputted at the rated 20 milliamp current. So there's the milliamps that we need. So let's go ahead and make some entries here. So we'll go here and put in 12 volts. And then the diode forward voltage, let's do this one here, the yellow one we just looked at. The diode forward voltage is 3 volts, and the forward milliamps is 20. And then we just click this button, which is find the resistor that we need, and there you go, 470 ohms. Scroll that up a little bit and you'll see, and that's how you hook it up, just like that. Now diodes do have a polarity to them. And there's one side of the diode has a little flat spot on it. If you look at it from the bottom, you'll see that the circular part on the bottom of the plastic has a flat spot. The flat spot goes towards the negative side. So now that we know that, we know that we need 470 ohms for some of these diodes, and then another one worked out to 1000 ohms. So it's time to solder all these up and get them connected up to some wires so that I can mount them up in here. Alright, let's get started. I've got a pretty nice soldering iron here. It's a Weller variable heat, and it's temperature controlled. It's warming up right now. I've got it set to about 650 degrees Fahrenheit. This is a third hand tool, very handy device. It will hang on to things for you while you solder them. So I can put like an LED in there like that, and then I'll be able to work with it, and it can hold it still for me. And we'll also need some heat shrink. I've got some of that here in white. I used to have some black, but I used it all up. So we'll put the resistor on the positive side of the diode, and we'll just cut this to a minimal length, leave about 1/4 of an inch on there. Anytime you do any soldering, you want to do what's called pre-tin the work. So you're basically getting a little bit of solder on there ahead of time. That way when you go to join the two together, you've already got a little bit there as a head start. Now another thing on the LEDs is the positive side lead will be longer than the negative lead. That's another way you can tell which is which. And also on the bottom, the negative lead will have a flat spot. So I'm going to cut these pretty short because they're going to get all heat shrinked up. And now we'll solder the wire to the resistor on the other side. There we go. Now let's put a piece of heat shrink around there and cover everything up. We don't want any exposed wiring at all. So let's cut that about that long. Really need to get some smaller heat shrink. Let's put that around there. You can use a heat gun to shrink this. You could use a Bic lighter. I just use the tip of the soldering iron. The heat that's there is usually enough to shrink it up. It just takes a little bit of time. Let's take a closer look. That's the positive side, all heat shrinked up nice and neat. Now we'll do the negative side, and then this is ready to mount up. I've tested all the lights and they all work okay, so now it's time to solder them up onto the wire harness on the bike. All right, all soldered up. There's all the lights. Let's turn on the key switch and see what we've got. Yep, there's the oil light lit up, and there's the neutral light lit up. Let's try left turn, ka-blink, ka-blink, ka-blink. And there's the right turn, and the high beam light. Ooh, pretty blue LED. All right, now we can mount these into the LED plate. Now the neat thing about these little LED holders is you just push them into a 1/4 inch hole. They just pop right in there. So let's see, that's the right turn signal. So let's make sure we got the right one. That's this LED right here. And then all you do is just push them in, and they'll make a little click noise. That's it. It's locked in place. And we just repeat that for all these LEDs, and then we'll mount it up. Okay, mount it all up. Here they are in all their little LED glory. Now they're ready to mount to the old handlebar lug here. I got some round head Allen bolts that should look really nice on here. Let's get these started, see how well the holes line up here. How good of a job I did on my machine work. Alright, that's mounted. Now let's get this key switch stuffed back in there if I can. Okay. Careful not to scratch my paint job here. Here we go. One key switch mounted up. Put the key in, push the button. The oil light went out, okay, so that's that. Yay, wow, that looks nice. All done, all mounted up. All the wiring tucked away nicely. How bitchin' is that? It took care of those ugly handlebar bosses. I chopped off all the extra stuff on the tree. Looking really clean and custom now. And I solved the problem there with that headlight that I had that blew out 6 volt. Well, it turns out that the same place I got the socket, Steadfast Cycles, they also have 12 volt bulbs for the Lucas headlights. I think the part number on those is 414 instead of 314, something like that. Anyway, that's on the way, as is some more fiberglass resin, and I can get glassing up the seat and tank. And there's only a little bit of wiring left, and that just has to do with the tail lights and mounting those up, and the brake light and all that stuff. But it's nearing completion. I'm pretty stoked about that. It's getting down to just a bunch of fiberglass work now. So that'll probably be next week's video. Anyway, hope you enjoyed this one. Till next time.
Electric.
Yeah, that's pretty dull. Wow.